large statistical observational sample to accomplish my some theoretical work, and one is the large volume or large area survey, and I'd like to explain why I need that. I want to identify a protocluster according to the spherical top-hat collapse model. So I first identify some concentration of galaxies and then go out to some distance. And if I have some way to convert galaxy luminosity to stellar mass and then stellar mass to total mass, then I can calculate the mean density of total mass enclosed within that radius. And if I reach the density value, which is equal to the critical density for spectral top-hat collapse at G equals 0, then that's the region that will collapse by now. Okay? And if that mass is greater than 10 to the 14 solar mass, that's going to be the protocluster. And in order to do that, the region that is observed has to be larger than at least about 20 megaparsec. So the sample I would like to have samples that are typically about 100 megaparsec size. So that's and also the density sampled. And another one is this. So this is the accuracy of number count, the galaxy count. And the reason is that, so I want to have the galaxy number count with accuracy better than 1%. So I'm just making a wish list, regardless of whether or not it's possible. So the reason is that there are recent measurement of W, the dark energy equilibrium state, that the dark energy equilibrium state averaged over the ratio range from G equals 0 to about 0.7 or 8 to be minus 0.9. So that was measured 2 years ago, assuming flat universe. And 2.5 years later, it was confirmed by DESI 3-year data. So there's 1 point at low ratio that W is minus 0.9. So in order to distinguish W equal minus 1, which is lambda CDM, with the quintessence model with W equal minus 0.9, we can ask how accurately we should measure the galaxy count. And in this plot, you can see this number count as a function of redshift. In the case of lambda CDM, the solid line, black solid line is showing the distribution, and the dotted line is when W equal minus 0.6. So you can roughly estimate how accurate this number count should be in order to distinguish W equal minus 0.9 from W equal minus 1 at 3 sigma level, and you need to have about better than 1% accuracy. So that will require large cluster samples. Thank you.